morning, everyone. It's so nice to see all of you here today. Welcome to the event, and we hope you're going to have an exciting day. I'm going to start by giving you a slightly different perspective, not from the physics side, but from the side of data, from the computer science side, because my background is in computer science. So technologies have always been influencing the way we have been developing as a society. So when we started cultivating the land, farmers created tools so that they can enhance the production of their fields, and we came together and we created communities, which then grew into cities, and institutions developed. And much later on, we've seen technology affecting us in very different ways. So for instance, steam engine that has been used as the engine to power trains meant that people could take trains and they could move much bigger distances than it was possible before. That has meant that their horizons have been expanded at the time, they were expanded at the time, and they were able to meet with people and see places that before it was just not possible, because obviously distances shrunk. But they could only travel in groups. When cars were invented, then you could buy your own car, and then you could travel with your family and visit relatives and visit even more new places. But more recently, we've seen inventions like the television opening a completely different window to the world, because television enabled you, and this is what the first televisions looked like, and I know it may look a bit peculiar to you that are in the audience of a younger age, but this is a typical television back in the 60s, and it was not color, it was black and white. So people that were colorblind didn't have a problem. So what did the TV do? The TV enabled us to view places, to understand about situations and things and people that before was never possible. And we've seen even more changes and acceleration of changes with inventions like the personal computer. Personal computers, of course, computers when they were first invented, they were only the privilege of big corporations and governments, and they were used for very specific tasks. But when we started getting them into our homes, they enabled us to do things like education and entertainment, play games that before it was not possible. But more recently, devices like the mobile phone they have completely changed the way we interact with each other. And the changes have not only been significant, but they have been really, really fast. And they have been so fast that as a society, we still don't understand all the changes that we are seeing around us today. And I'm just going to try and illustrate that point and how big changes we have seen. So this is a photo of St. Peter's Square from 2005. So this is at the time when people were waiting to find out who the new Pope was going to be. And as you can see from this photo, there's only what appears to be a screen of a smartphone right at the bottom there on the right of the screen. So this is 2005. This is 2013. This is 8 years. This is a massive change because all of these devices are generating data. In fact, if you're tweeting today, if you are posting on Facebook, if you're talking to your friends, if you are watching a YouTube video, if you're generating a YouTube video, you are generating data. So all of us now are not just consumers of data, but we are actually producing a lot of data. And this has been so dramatic in terms of speed of change that actually we don't know how to handle so much data. So what has happened is we have changed the way we're doing things. So it is being said that we're spending, on average, something like 11 hours daily consuming information. So when you're tweeting, when you're following your friends on Instagram or on Facebook, you are consuming information. When you're watching TV, when you're playing games, all of this is information. So we have been evolving, but in a bit of an unpredictable way. So now we're all walking around with mobile devices, and some of you may be carrying more than one device. I typically carry 3, a laptop, an iPhone, as well as my iPad, which is a bit ridiculous, but different devices enable me to do different things at times. The other thing that has been astonishing is that when you use your mobile phone, you no longer view it just as a device that you give it instructions. You want it to do things on your behalf. So we're not just talking about instructing our computational devices to do things for us. We're talking about interacting with them, delegating to them our high-level goals. So when you call your phone stupid, I can reassure you your phone is not stupid, but I hope it gives you a glimpse of how we have started to look at our devices in a completely different way, ascribing to them almost human-like characteristics. And the kind of data that we are generating is not just structured data, so it's not just about going to your bank, withdrawing money, and then you generate a transaction. A lot of the data that is being generated nowadays is actually unstructured data. It's photos, it's audio, it's video, and these are projections and in terms of generation of structured versus unstructured data up to 2015. And the red bar is actually the unstructured data, so you can see. But you're all contributing, again, to this. So what are we talking about? You will be hearing, I guess, in the press or when your teachers talk to you or when you talk to each other or in social media, a lot of terminology. So what I'm going to try and do in the next few minutes is try and demystify some of that terminology. So hopefully after this talk, you will have a much better understanding of what we are talking about. So you may have heard of data science. So what's data science? You know of mathematical sciences, you know of physics, these are traditional disciplines. You may have heard of computer science, electronic engineering. Data science is this new discipline that is emerging, which is very much an amalgamation of disciplines or different disciplines coming together to deal with this proliferation of data that we see and the problems that data poses. So it's not just computer science, it's not just statistics, it involves business experts, finance experts, it involves domain experts, but it also involves social scientists. It involves scientists from other areas, physicists, but it also involves humanities experts. Because data, for most of us, when we first hear about data, maybe we think it's all about the application of techniques and you get some results. It's not just about that. It's also about the ethical implications of making use of data and making decisions based on data that will affect people's lives. And this doesn't come under traditional computer science. This comes under ethics, it comes under philosophy, it comes under law. So all of these disciplines need to come together if we are to change the way we do things and make progress in this field. So I hope I have demonstrated that all of these devices that we are using, they're generating a lot of data. There are a lot of sensors. Street lamps have sensors. Your car may have a sensor. Fridges, washing machines have sensors. So all of these devices that perhaps you don't traditionally consider as computational devices or items, they do have sensors. And all of these generate data streams. So when you have a lot of data being generated, so massive volumes of data, and for instance, in the domain of physics and astrophysics, there's a lot of data being generated through the Hadron Collider, but also through telescopes, then you have massive volumes of data. When you have a lot of different types of data, so you have banking transactions, you have your Amazon transactions, what you view online, what you like or don't like in social media, you have variety of data. And then you have data arriving at really fast speeds, for instance, like in experiments in CERN, or in financial markets where we see data arriving and transactions happening within splits of a second. That's velocity. Then all of these three generate what we term big data. So big data, just to differentiate from traditional data, you typically have large volumes, you have variety of data, and you have velocity. And the problem that we have here is that we don't have the techniques to actually resolve issues and make sense out of different streams of different types of data coming together. So that's why you may be hearing a lot about big data, because we need to develop new techniques to handle the challenges that big data throws at us. Analytics is terminology that is used a lot, and it means a lot of different things to different people. Companies nowadays, they are really motivated to use analytics. Not all of them necessarily understand what it means. But the simplest explanation is that analytics is obviously it has to do with data. It's the application of techniques, and these can be quantitative social science techniques, it can be statistic techniques, it can be different types of techniques that you apply to understand the data. It's about predictive models or non-predictive models. So analytics is an all-encompassing term. And there's a lot of fuss now about AI. So how do all of these link together? Artificial intelligence is a sub-area of computer science, and I'll talk a little bit more about that. But artificial intelligence involves essentially creating new methods that are smart. So it's all about creating smart systems, and I'm going to elaborate on this a little bit further down the talk. So we talk a lot about data, information, and knowledge, and the three terms are actually not the same. They do not mean the same thing. So data is the result of transactions. You go to your bank, you generate a transaction, you post something on Twitter, that's a transaction. Someone posts a video on Instagram, that's a piece of data. Information only comes as the result of processing of data. But knowledge then is something different. You go a step beyond information. It's all about understanding the patterns that you see, understanding the why, and then using this to generate good decisions. So just because someone has data, it doesn't mean that they have knowledge, or if they say they have big data, it doesn't mean that they have big knowledge. So we have to be careful, because at the end of the day, it's all about generating value. And value can be the value for a company, but it also can be the value for the greater society, the greater good. So it's not about chasing the bits and bytes, as this image demonstrates. It's all about the knowledge, the insights that you can extract from the data, so that you can use these insights to make better decisions and act. So there is going to be a range of steps. You cannot get from data to knowledge without these necessary steps. So it's all about, in the first instance, capturing the right data. Organizations nowadays, they say they have data, but whether they capture the right data or not, that's a completely different question. And then you go through the stage of analysis and modeling, which enables you to do more complex things like getting into the knowledge, as I was saying earlier. So to get into this knowledge, I would like to tell you a little bit about the different levels of analytics techniques that we have. And we typically understand these, or we explain these, by looking at two axes: the value that you get out of analytics versus the difficulty or the complexity of the methods that you use. So if you have historical data, what you do is you try to understand the past, and the kind of question that you are trying to answer is what happened in the past. So you are in the realm of descriptive analytics. If you then try to pose the question why something happened, not just what, then you progress a step up and you are in diagnostic analytics. If you understand why things have happened, then you can take it a step further. And then you can try and apply techniques that will enable you to predict the future. And prediction here, we have to be careful, because no technique is going to give you 100% accurate prediction. If people say that to you, they are lying, I can tell you that. So you are in the realm now of predictive analytics, and things get more difficult. If you are able to do predictive analytics, the ultimate step is to do prescriptive analytics. So in predictive analytics, you try to predict the future. In prescriptive analytics, you try to manufacture the future. So it's not just about understanding and predicting, you make the decision about the future. But for instance, to give you a more concrete example, imagine you have a company like British Telecom, for instance, or any other organization that has customers. They can understand them so well that they can predict their customers' behavior in the future. But prescriptive analytics, if they were able to apply prescriptive analytics, would enable them to essentially change the behavior of their customers and influence them in their buying behavior and in choosing the products that they offer rather than a competitor. But that's really difficult because there's this axis, you go from information to optimization in decision making and from hindsight into insight and foresight. But actually, the further up you move, the more difficult and complex the methods become, the more domain-specific, but obviously you derive more value. But that's how we develop analytics techniques, and we apply them in different domains. So typically we have data, we analyze the data, and then this is the stage that most people, at this stage, they will take action. They will make a decision, or if they are a business or a company, they will inform their strategy. And this is the descriptive analytics. If they start wondering why things have happened, this is when, from a science point of view, you enter into developing theories and hypotheses about behaviors and the patterns that you see in the data. So you're starting to get into diagnostic analytics. And from then on, and this is where things become interesting for me as a computer scientist and in my own field, if we have theories about why we see certain patterns in the data, there are advanced techniques that we can use from artificial intelligence, and we can develop really complex models. We can develop whole societies that reflect what we see in real societies, but these societies that we develop are artificial. They are encoded into software systems, and we run them into machines, and we can run very complex simulations, and we can see artificial data being generated by this system that is supposedly representing what is happening in reality. But if you have real data and then you have artificial data, and what you think you're doing is you have an understanding of the domain, you can check the artificial data versus the real data, and that's when you have an understanding, a much better understanding of what is happening. So you're now in predictive, and you can even go further down into prescriptive analytics. And this is the kind of work that, this is aspects of my own work. So I try to understand complex systems. And for instance, one of the interesting questions for me is we see in a lot of different domains, fluctuations. And one such domain is financial markets, or markets in general. And we see these ups and downs, and we know that there are thousands of traders that are interacting with each other, but if you ever attempt to ask a trader how they trade, they will never tell you. So we try and hypothesize how is it that traders interact with each other, and we see these ups and downs in the market. And in some cases, we've had real data from the market, and we have been able to generate an artificial market that we have encoded with hypotheses as to how traders behave, what kind of risk attitudes they have. And we have been able to reproduce patterns that come very close to the ones that we see in real life. And you may think here, okay, so is your purpose to make money? No, our purpose is not to make money. Our purpose is to understand what is happening in the system, because if you have a good understanding of the system, imagine you can use this understanding then, if you are a policymaker, to prevent financial crises. You can enact new policies to stop a system from going into crisis. You can, because then you have an understanding of how the system works. So that's a potential application. We can also use these kind of complex simulations to understand other phenomena, like, for instance, how social networks are being formed, how they evolve. And what you see here is a simulation of different agents, different nodes in a social network, and how they find each other, so the different colors encode different characteristics. And the nodes interact, and if you look at the simulation, then you can see that all the purple, all the red nodes, they congregate together, they find each other in the network, and no matter how many times we've run the simulation and different configurations, you always get a very similar result. So that is helpful, for instance, for businesses, because if they are able to identify customers with similar characteristics, then they can use this information to give them ideas for products to buy. So I talked earlier about artificial intelligence, which is my own field of expertise. So we've been hearing about AI in the last 3 to 4 years. But artificial intelligence is not an area that emerged now. It's actually it was born back in the 50s. So there was a workshop in Dartmouth in the United States, and a lot of eminent scientists came together and they decided that this is a new field and a lot of progress would be made if they joined forces. But unfortunately, they realized after a few years of working on this that intelligence, because they were trying to on the one hand, understand human intelligence, but then almost like reproduce it or create smart systems to emulate human intelligence, it's not that easy. So we saw a slump in interest, and then we saw another peak of AI with expert systems back in the 80s. But expert systems were these very inflexible systems that were encoding human knowledge. And unfortunately, they were not very flexible and they didn't deliver on their promises. So we saw what we refer to as an AI winter, which means nobody was interested to do AI at the time. And now we see the big comeback. But we see a big comeback. Why? Because we have a lot more computational power. We have a lot more data now. Now we have truly large volumes of data that we can use in some of our techniques. And then we've been able to make progress in algorithms that, for instance, are now called deep learning, but they are based on neural networks that were developed many, many years ago. So we are now seeing this big comeback of AI. And the AI perspective is, of course, that if you want to have intelligent systems, they need to be able to adapt their behavior. So the idea is you have a system, there's an environment, you get sensory data, something happens in the brain within quotes of the system. Maybe there's a machine learning algorithm, and then action is taken, and then you have this cycle again of the environment generating sensory data and the agent or the system acting. So that's where we've got the idea of learning, because you acquire new knowledge as a system which causes changes in your behavior. And as humans, we do it all the time. We constantly learn. That's why we have the concept of machine learning. So there are different types of learning. We have supervised learning, where you need to have labeled data. We have unsupervised learning, where essentially you're trying to identify patterns in the data. Reinforcement learning, that you are trying to learn sequences of actions, like in games, for instance. And you have an intermediate type. And we've seen AI and machine learning making a lot of progress in a number of applications, and I'll show you a little clip. So we've seen them being used in driverless cars. Netflix is using machine learning and AI to understand their customers, all sorts of different domains. So I hope this illustrates how far we have come. So you can see a robot here. This is Boston Dynamics doing some really amazing work. It moves like a human. Now watch this. This is amazing. I cannot do that. So we've made a lot of progress. And we can use AI in a lot of different domains for public good. So for instance, we can understand, using machine learning and natural language processing, how patients view their doctors, what their needs are, so that we can inform policy. But the problem with learning is that very often what happens in the brain, the mind of the system, is like a black box, and we don't know exactly how some of our machine learning algorithms, for instance, work. So that is a problem, because if you have an algorithm that is making decisions on your on behalf of a company, and you don't understand how the algorithm works, then that obviously may affect you in a negative way. So this is where ethics, biases come in, because a lot of the times we use data sets, and the data sets that we use may be biased. So the decisions that algorithms may be biased in themselves. So we need to be careful. We need to have the right legal and ethical frameworks in place. And as you go about your everyday lives, you may not realize it, but you leave a lot of data behind. And there has been a lot of work that has been done to demonstrate actually how much you leave behind and how much these systems can learn from you. So every time you tweet, every time you say something, and there have been instances, there have been issues that have come to the front, to the limelight. There have been occasions where this information, this data, your data has been not necessarily used for the purposes that you thought were being used. But data is not just about us in the Western world. Data is, and the use of data, the power of data, we also need to harness it so that we can make a difference to the World Wide Web. Sorry, to the worldwide world. So someone sitting in Africa, they may be having a mobile phone, but they're not benefiting from data in the way perhaps that we are. So it's really important that we work together to make a difference in the world. So what's next? People imagine perhaps a Terminator-style future where we've got machines and they've taken guns and they are attacking us. But this makes the assumption that we have developed systems that are really clever and they can reason. And we cannot, our systems, our AI, we have not developed systems yet that are able to reason in the same way that we are able to. Maybe we're going to see a human 2.0 emerging, where your brains are actually enhanced, augmented through embedded processors. So are you going to be human? What is that going to do to our sense of autonomy? Who's making the decision? How autonomous am I if I have an implanted chip? Or are we going to see a society 3.0 where we have little robots or even synthetic systems and humans like human 2.0 interacting with each other, and we're going to see completely new norms and institutions emerging. So I would like to invite you all to help us build a good future for all of us, and that's why you need to invest in science and engineering in the future and join us and have careers in science and engineering to build a better future. Thank you very much.